we are talking about the task, right? Am I right?
Mm-hmm.
So last week we said what will be the proof for we built artificial general intelligence? What task it will be? Am I correct? So can anybody share their answer with me? Shaku?
Tasks would be like say general purpose, like say driving. Driving could be one aspect of artificial general intelligence.
So driving. So we talked about what will be the necessary condition and what will be the sufficient condition for the artificial general intelligence. So I think driving is definitely one necessary condition. But we cannot say if something that can drive itself or learn to drive itself is not human level of intelligence. In the world model paper we share, I referenced there is a model, there is a car racing game, and the reward is if you stay on track as long as possible, you get the point. So at the end of the training, it looks like it is driving, but even though this model can learn how to drive, we cannot say it has enough or sufficient capability for human level intelligence. Am I right?
Yeah.
So any other opinion?
In a more general sense, maybe if the system could use the learnings of one data set and apply it to a totally different data set, maybe then we could classify it.
Yeah, that's the idea of the artificial general intelligence. This general part is where we can learn things from one part and apply it to other part. My question here is, what will be the task that we can say this learns how to learn one things from one domain and apply it to another domain. So this academia has some bad habit. When we know we have to do something, then we tend to think minimally. Right? So we know we have to learn from one domain and apply to another domain. And smart people already knew it, so they named it transfer learning. So transfer learning is the idea that we should learn from one domain and transfer this knowledge to another domain. But what actually they did when they talk about transfer learning, it's like when we train the image classification model for one set of the model. So let's say we trained this image classification model using one data set. Data set A. And when the majority of the transfer learning is how we can apply this model to data set B. Right? So let's say data set A is a image captured using, for example, camera A, which has a different camera than the camera B. So that's what they usually study. So their main innovation was when you try to build some kind of image model, then you use already trained model. this one is a very famous de facto image classification model, and they use the lower layer and lower convolution layer, and there is a upper fully connected layer. And what they usually do is they remove this fully connected layer and use the same layer and train new fully connected layer for new application. Do I make sense? So that is the pitfall of the academia. When you say, oh, this model should learn from one domain and apply to another domain, people tend to minimally achieve that and claim that this is the transfer learning. So in this case, even though you are right, this thing should learn from one thing and apply to another, you need to more specific about what do you mean by this and this. Otherwise, people will choose a very similar domain. And
so for the same image example, what I can think of is like first you train the AI to detect do the feature detection on a data set to classify. Like that data set has a bunch of classes, and now you have a new data set that is completely different from the original data set, but the classes are similar. In the sense the meaning of the classes are similar. So you should train the model to understand the correlation between the existing class that it has already learned and the new class, and try to classify the new images based on the same model that it has already learned.
So what is your point, Sana? Is it this question or?
No, I think that is what the true artificial general intelligence would be, right? So when you understand one concept, and when you're reading something new, and you, to understand the new concept, you try to relate it to the concept that you already know. So isn't that artificial general intelligence?
That is, I agree that it is artificial general intelligence. We need to operationalize it. What I mean by operationalize it is you have seen the obstacle challenge, and before that there was Atari. Or, you have Animal Olympic. And there was Wisdom. So each one is a task, and when we as a computer scientist people talk about the task, we want this level of the detail. So when one says learn from one domain to apply to another domain, that is how philosophers or psychologists would say. But for computer scientists, we need to make every detail clear. Okay.
Professor, when I was reading about multitasking AI, I came across Google's multimodal, and it does 8 different tasks. So could we classify that as intelligent?
That is we need to see more detail. So can you share the paper in the Slack? Okay. Yeah. It depends on how you say define things. Yeah.
I have a So while using the transfer learning, right? So let's say the data set A is all images for car and cat. So are we using that model after training to classify something else like dog or anything, or it has to be belong to the same class?
Depends on the how you look at the. It probably depends on the situation. Let's say only you have the cats in your image data set. Let's say you have a 1 million cat image. Then what can you build?
A classifier for cats.
Can you build a classifier for cat if you have only image for cats?
You can build a classifier for cat breeds,
Features.
but not. We can build a classifier for cats breeds, like it is a tiger cat.
Cat
Persian
breed,
cat,
yeah, cat breed, okay.
But not
We
about
can, we
like
can
the
make also
here.
classifier.
Like the
for
binary
cat.
classification,
Binary
whether it's a
everything
cat
is-
or not cat.
No, cat or not cat. Yeah.
Cat or no
It's
cat.
not meaningful, but.
But if we only have the image for cats,
You don't have other images.
we don't have other image.
But other image is
Oh.
infinite. I mean,
Yeah, other image is infinite. So, what do you mean by infinite? So what?
I mean, the all images other than cat is huge. I mean,
So yeah, it's a huge. So you mean because it's a huge, it should not be there or it should be there?
I think even if we don't have those images, we should be able to do classification.
I don't agree. If you have only cat images, then you cannot actually build a binary classifier for cat. The classifier will say everything is a cat image and get the 100% accuracy. Do I make sense?
It includes a lot of false positives.
No, there is
We can.
No, when you test it on a new data set.
In new data set, it will basically say everything is a cat.
No, because from the existing image, I will get some features. Like so, all the cat feature has some common features which is not present
That is
in the
a
dog picture.
human level of thinking. You are not really understanding the neural net.
So
You think neural net is your brain, but neural net is not your brain. Neural net is what it does is whenever it sees an image, image, it guess if it is a cat or not, right? And if it is a cat, then it how I say, it does not change. If it is a not cat, or you get an error, you update to minimize the error, right? Then let's say this neural net model will at first say, oh, this is cat. This is not cat by 0.5 probability. But every time when it says this image is not cat, it will update to say everything is a cat image. So in the end, this neural net will be trained to say everything is a cat, because everything you see is a cat, and the ground truth is a cat. You don't know no cat to what?
Okay, so we need some negative examples.
Yeah, we need some negative example. So for cat image classifier, let's say you have 1 million of the cat and 1 million image of everything else, right? Now your model is trained to classify, for example, let's say there is a car and there is a cat, right? And this model will try to differentiate between car and the cat, and while doing so, it will probably develop some kind of low-level features, like some kind of flurry thing. So in the lower level, it needs to differentiate things like, is this metal or is this flurry? This is a very, how I say, human-like description. The actual thing does not go like that. The actual thing goes, if you have an image and you get the convolution filter, you can think convolution filter, if you guys have any image processing background, it's like applying blurring or sharpening. This is one example of the filter. So if you apply sharpening, you get some kind of metric about how sharp the edge is, right? And the flurry thing has a low sharpness on edge. Metal thing has a sharp edge, so it has developed this kind of features. And at the end of the day, it classifies if this is a cat or not. And let's say we want to build a dog classifier here. Then many of the lower level features here will be still useful. Do I make sense? So many of the things just still be useful. It requires is this metal, is it flurry, or in more high level to differentiate from cat from dog. It has a features like is nose shape or ear shape, things like that. So when you build a dog classifier, all of these features are still required, but you just say different logic here. If it is more dog-like nose or dog-like ear, say no, because you are cat classifier. But if it is a more dog-like nose or dog-like ear, then say yes. This logic is done in fully connected layer. So this lower layer is still useful in the dog classifier and cat classifier. So when we say transfer learning, this is how I say what they usually do, right? So
one question. So in the lower layer, when you're training it on the second person dogs in this case, do you do gradient descent and update the weights on the lower layer as well, or only on the fully connected layer?
There are two things possible. So people study if we update all the layer, then still it is useful. The training is much quicker, right? Because you only fine tune small things. The major thing is already there. Or some people say, oh, you don't even need to train. You can just train fully connected layer. And the performance will be theoretically, if you do full update, then it will be, let's say, 100%. If you update only fully connected layer, it will still be like 90%. Do I make sense? Yeah. Okay. So any other opinion about last week's question?
For this AGI test, what I feel like we can define agent like has ability of AGI when they have ability to learn in a unknown domain given the particular environment, conductive environment. Like if the agent had given the conductive environment for a driving a car, he can learn the driving the car. So that have like human-like intelligence. If the agent can given the environment to learn the languages, he can learn the languages. And if the agent can have given the environment to how to swim, he can learn the swim. So
yeah.
he has
So
the capability.
let's say you have 16 kind of Atari games, right? So you have DQN. You can use anything, PPO, any reinforcement learning algorithm, and you say, of these 60 Atari games, when this model is trained using this environment, it achieves some performance, right? So in a sense, this model can do many things, right? That is what you are claiming, right?
Yeah. So.
So
yeah, kind of thing. Yeah, it is doing the many things given
yeah.
if it has like conductive environment. So
Yeah.
there are always a possibility which we don't know as a human, but if we have given the conductive environment, we can learn about it.
Yes.
So that unknown thing also should be there in the.
Can you say then DQN or PPO has a capability for human level of intelligence?
In algorithm wise, I don't know much about PPQ.
Yeah,
So,
you know the famous Atari game algorithm.
yeah.
You already used the one, PPO.
Yeah.
It's nothing new, that much new. It's an old algorithm. So anyway, this algorithm, when given in an environment, meaning different games, it learns how to drive, how to do some game, right? This
To some extent, it has.
yeah. So this satisfies you one you mentioned. Then do you think this one has a capability for human level, it has a necessary and sufficient. Do you think this PPO algorithm has achieved human level of intelligence?
I can say it's maybe like in some extent 100% not, but yeah, it is able to learn the different game given that different environment. So to some extent, it is achieved that level, but not in like fully.
So that's the, you say it's a yes and no kind. So it's not, you are not making.
It is not sufficient, but it can say it is necessary.
Yeah. So what I agree that it is not sufficient, right? Even though human, let's say you go to arcade center, there are many games. You can do many games, right? You can learn many games. So it's a necessary condition. But even if model can do all of these video games, it's still not. Somehow we feel that it is not sufficient.
Yeah, it is not sufficient but necessary.
Yes. So for human level of intelligence. So any other?
Just a question, how are we defining human intelligence?
It's
What sense?
you should ask that kind of thing to the philosopher.
Yeah.
Yeah.
I mean, in order to say and in order to develop a criteria to say that a machine has achieved human level of intelligence, should we not begin by defining human intelligence in terms of computer science?
That's how I say mathematicians are actually better than that. So that kind of question is almost useless. Yeah, it has not been useful. So the question is like, can you define flying?
No, I'm not actually talking about human intelligence, but when we say the machine has achieved this level of intelligence, should we not define that level?
So isn't that the Turing test?
Yeah, the Turing test.
Turing test is one of the.
Yeah. So because there was a problem like this, they made the Turing test, which just defines that the actions of the machine should fool a human being into thinking that the machine is human.
So
There is called imitation
all
game.
I'm saying is, what do we want the
Yeah.
machine to achieve?
Basically whatever it's programmed to do the task, it should do it like the human will
So
not
if
know
it's
it's a machine or a
no,
human.
I know what the Turing test is.
So-
I'm not talking about that.
Because-
When we are looking for criteria to say that it should achieve some level of performance or something, what are we
I
looking
believe
for?
what she is trying to say is, can we not convert that human intelligence into some kind of mathematical
Quantitative.
formula
You want to
where we
I
can
don't
compare?
quantify.
Leave human or whatever.
No.
Leave human out of this. We are saying we need it to achieve some level of intelligence. What is that level?
That level is being able to.
We
fool
can't be
humans.
abstract and be saying we want it to achieve some level of intelligence. What is it that
I
we're looking
think
for?
can you give me some example? I don't get. So human language is very abstract. So that's why if you use human language to build intelligence, then we fail. However, programming language, computer science language, is very precise. That's the level of the tool we should use. So if you say, please describe the level the intelligence should achieve to say this is a human level, all of the thing, like a level, human, everything is not defined in a programming world level of the thing. So that's why I think if you can make it much more concrete. Can you rephrase your question again?
the way
Yeah, go ahead.
the way I think her question is, if you want to know the machine whether it's a human level intelligence, I think she's trying to say that what is the criteria? Let's say if you are
What is the
if you are
threshold
machine,
beyond-
like should it be able to speak, should it be able to drive, so what are the kind of criteria so that you can define, okay, this machine achieved a human level intelligence. Am I right?
Yeah, something like that. I mean, what are we trying to discuss here? I mean, is it a machine's ability to multitask, or are we trying to find a quantitative level to its performance? Or I kind of lost track of what we're discussing. I mean,
I think I understood the main problem here. The thing is, you are trying to see like a particular task, how, like you are trying to define if a machine is doing a particular task, at what point do you tell that it has reached human
Yeah,
intelligence? Or how many tasks if
no,
it's able
is
to
that
do?
what we are discussing here?
Yeah, no, that's not.
What are we discussing
The-
here?
we are trying to
lost track
discuss
on this.
other than the criteria for artificial general intelligence is not just being able to do one task like a human being or do multiple tasks like a human being, but there is some other criteria. Like along with being able to do multiple tasks, there is a certain way of doing it. It's the approach in which it's doing. We are trying to find what is the approach in which the program can take that will make it more human-like.
But what is your
let me. So, actually, one way you can do is see the video again. So that's why we record this thing. So you might see last week's video and clarify the question again. So let me rewrite it again. So let me write it here. So let's say there is a task. And what is the task? That is my question here. That if an agent achieves it, we can say it achieved sufficient. No, it achieved human-like intelligence, and it means simply sufficient condition.
the minimum task it should perform in order to be classified?
It is not minimum.
Okay.
Sufficient is not minimum, right? Sufficient is over.
Okay.
Even if it does not do this, there is a chance that still this might be already achieved human level intelligence, right? It is overqualification. Sufficient questions. If you do this, of course you can do this. Necessary is something that you need to do, right? So, what is the task? If an agent achieves it, we can say it achieved human-like intelligence. So we had someone says car driving, and I said if the model learns how to drive a car, still it does not seem right. If Bhaskar said if a model can do multiple things given multiple environment, I said the PPO algorithm or something like that achieves in they are basically same algorithm applied to many different environment, and it achieves intelligence there, but still is we cannot say it is a human level intelligence, right? Then what will be the task? Like if this agent achieves the obstacle tower challenge to the every perfect score, can you say it achieved the human level intelligence?
No.
Okay, so then what will be the task like?
Like given any environment, if the agent is able to learn and any environment.
That is this thing. Given
No,
any
no,
game
no.
environment.
No, not the
Understanding
game. Like
emotion.
game for one example.
Yeah.
Driving another set. Other way language learning.
In the
another
game,
set.
there are many things. There are driving, jumping. There are many things in the
If
game.
we can define emotion and
Emotion.
the agent can understand the emotion.
So what do you mean by understanding emotion?
Like see, it can be sad, happy.
It's like many times we say the same word.
So let's say you say one sentence, I feel sad, and human labels it, oh, this one is sad. And let's say we have a 1 million sentence like this and 10 class, then this model will achieve some level of understanding emotions, right? Can you say this model has achieved the human level intelligence?
This is just a parsing of the word, but the emotion has a broader range. Like we cry, we
Motivation.
get the tears because we are sad.
So
we get the tears when we are happy.
You have
So-
a video of
Yeah.
tears
Yeah.
and label it sad, right? Let's say we have a 1 million video like this and build a action classifier which labels this emotion. Then do we have the artificial general intelligence or human-like intelligence? Of course, human-like intelligence can do this, right? What I mean is, if this model does this, can you say it is sufficient for?
So after this discussion, what I feel like there is not one particular task is sufficient, but all individually is necessary. So if we combine all the them together, if we are able to combine them, then that is like become the sufficient condition. Like emotion is necessary, but not the sufficient. Learning the different area given that particular environment is necessary but not sufficient, and those together is also necessary. So yeah, it's like we somehow, if we compare with the human intelligence, so we have to combine all the tasks together for making it sufficient, because as a human we can do all these things.
So you are saying is mathematically, if we add lots of necessary condition, can we achieve the sufficient
necessary,
question?
if they are able to learn lots of necessary conditions, like, and
What do you mean by the learn lots of necessary condition?
one thing like we talked about like emotion, it is just one of the phase of the human intelligence, one of the module, I can say, if we talk about in a language.
Then how many modules will be there?
That's the thing. So we cannot define like infinite module create. So whatever comes to us, we learn it. So there should be some scope always. We learn the unknown module and unlearn which is not required. Whatever we saw into our childhood, we don't remember it now. We don't know how to do it. So we also like learning and unlearning.
Pascal,
as we go.
It's
It's much broader.
yeah, too much.
Too
Yeah,
much broader.
too
Yeah,
much.
but if we talk about
It's like if you write if this, do this rule, and if you build a 1 million rule, or 100 million rule, or 100 billion rule, can build a human-like intelligence.
Yeah. Yeah, that's why I think this discussion was going on somewhere. So at first, going into this discussion, we should define what is human level intelligence. I think C also wanted to try that. How can we define the human level intelligence, and then we can compare with that. Because if we comparing just human level, so there is no limit for human level intelligence. That's what I was thinking.
Yeah. So it's like a evaluation problem. Do you remember if I say there is a image caption model, right? And there is a image and caption. And if we can evaluate if this caption is right or wrong by algorithm, we actually achieve the human level intelligence, right? It's crazily very difficult to write an algorithm to evaluate this caption if it is right or wrong
Because it should be
according to the algorithm.
Right.
But human has no problem. It's immediately, right? That's the human intelligence evaluation. Let's say you have a one model. If you want to build some algorithm that evaluate every aspect of it, its behavior, then if writing this algorithm is impossible. However, when we see its behavior, we know immediately, oh, this one has an intelligence or not. Do I make
Every
sense?
aspect of images you are talking about.
Pardon me?
So I didn't get you. Like, are you talking about if it is able to learn the every aspects of images? If we have given the images, they are able to get what the images mean.
No. What I mean is image
Captioning.
Yeah, image captioning. So let's say you have an image caption model. It generates text from the image, right? And now you want to evaluate this caption, if it is right or wrong, right?
Yeah.
And what I say is it is almost impossible to write a mathematical algorithm to evaluate if this sentence is right or wrong, right?
According to images. So basically, are we able to captioning the images?
No, are you able to evaluate the caption?
Image caption is correct or not?
Yeah,
Accuracy,
if
like-
this model is correct or not, right? The same goes with the intelligence. It is you want me Professor define what is a human-like intelligence before this discussion goes somewhere. It is impossible to define what is a human-level intelligence, but it is very easy for human to judge if this model has a human-like intelligence or not. Do I make sense? So that's why I said trying to defining what is the human-like intelligence is very useless, right? So now I think you at least got the difficulty. You now understand how difficult it is actually to build a test that something is human-like intelligence, and you will see this again and see, oh, this guy is really genius to develop this task. So if an agent achieves it, we can say it achieves human-like intelligence. Turing test is right? If an agent can pass the Turing test, we can say it has a human-like intelligence. But the problem is it's just too difficult to actually build some model that can pass the Turing test. So I would like to propose another test, and this is almost 70 years since Turing test has been published. So we need to have some kind of more update about the Turing test. So I know Turing test is actually right, but it does not mean it is useful for us now. So the academia for 70 years worked hard, and now one of the problem of the Turing test is that we know that if a model passes Turing test, this has a human-like intelligence. But let's say we are here, and it does not say anything about how we can go this way, right? Once we pass this test, but we will be successful, but this test does not give me anything. For example, during test, human can ask a question requires some knowledge, right? World knowledge, like what color is an apple. Then the Turing test does not tell you anything about where the agent can acquire this knowledge, right? So now we have a slightly different approach we call environment. So the idea behind the environment is that, by the way, this is a simulated environment, or simply speaking, game. This is has a similar goal. If this passes some score, human level score, we can say it passed. But this environment contains all the information the model needs to solve the task. See the difference? Here in the Turing test, you have to acquire the knowledge anywhere. It does not matter where you get the knowledge. So it's a difficulty with the Turing test. But in the simulated environment, every information should be given from the environment. Do I make sense? Is this clear?
So, for example, there is a game, and within the game there is a main objective, and there are like hidden side objectives, which are bonus. Like, not everyone has the knowledge about these hidden bonuses. So if you have seen many games have some bonus levels or hidden treasures that many of the main users will not even be aware of. And only some people who explore and accidentally discover it will get to know about it.
That is not what I mean. It is like if we want to test the model how to learn how to driving, we want every information it requires to learn how to drive inside the environment, right?
Okay.
That is the what this means.
Okay.
So, and there are things like Atari, Wisdom, or you guys have just seen one thing, obstacle tower challenge. This kind of thing is environment. And let's say my goal is here is we want to build a game that says if the environment solves the game, we have a chance that this model has a more human-like intelligence. So what I mean here, this Turing test is binary, on or off. But for Atari game, if the model can do Atari game, we think this is smart. If the model can do, let's say, things like Wisdom, do you remember the go to Bluetooth thing, the embedded languages? So Wisdom thing, and there are things like obstacle tower. And let's say we want to build a game here. We want to build an environment that if we the agent pass this game, then we have a more human-like intelligence than the previous one. This model can do everything here, right? So that is what makes this more like necessary conditions. The Atari or Wisdom or obstacle, this is more necessary condition. But we want to build something that can be a sufficient question. That is, if we solve this game, we can say it has a human-like intelligence. So that is the main idea behind this Part-6 test. So let's say, if an agent learns how to speak given a proper environment, it is my, argument, my claim that is not proven yet, that we can say it has achieved the human level intelligence. So that is the Part-6 test, and the real devil here is given proper environment. So I said this in environment, all the information that is required to solve this task should be given inside this environment, right? So what is the necessary information to learn language?
Grammar and articles.
Context.
Context. So context is a little ambiguous. Can you give me an example?
Intent.
Yeah, so when you're using a particular word in, say for example, apple, when you say I like to eat apples, you're talking about the fruit, whereas
Apple of mind.
yeah,
So-
apple of-
What I mean is to how an agent can learn I like to eat apple. How the agent can learn words like I like to eat apple. Before there is a context that the agent wants to eat apple, it at least has to know there are words like I.
Alphabets.
Alphabet,
dictionary.
Dictionary. Grammar and dictionary.
dictionary. So if I give the baby grammar book and alphabet book, can this baby can learn the language?
Teach it to read.
There should be some communication in the environment.
Some communication, that's so good, some communication. So what do you mean by the communication? What is the essence of the communication here?
Somebody has to talk with the baby.
So
it has
there
to
is somebody
Who already has the knowledge.
and there is a robot. Somebody with knowledge. So let's say it communicate. So what is the communication here? What is the essence of the communication here between the somebody with knowledge and the robot baby?
Verbal communication.
Pardon me?
Verbal communication.
Yeah, it's a verbal. So let's say it's a verbal. But what is the content of this verbal communication?
Passing the information.
So how it passes the information? If a mother reads the Wikipedia article, every Wikipedia article to the baby, it is passing the information. Can the baby learn the knowledge?
No, it doesn't.
There are some kinds of consequences
The
or
reaction.
punishments. Yeah, the feedback that.
Punishments,
I would say reaction. Like
reaction.
Whatever reaction.
Yeah.
So what do you mean by the reaction?
So let's say if you say, for robot come here, right? If the robot comes to my location and the baby will assume that the word of come here is to come back. Like there is change in the environment.
The adult say, "Come here," and when it comes, gives a apple or reward. Do you learn language like that? Sanjay, come to me, and mother give you candy.
I mean,
Or it's not
see,
directly on the rope. Go ahead.
so whenever, for the first instance, whenever you want to know the meaning of mom or dad, right? My mom has to, or someone has to repeatedly say, it's your mom, it's your dad, you know.
Repeatedly saying.
First,
So-
it needs to know the word, and then it has to understand the meaning of the word.
So if say you have this poor robot, let's say you build another robot, and it says, I'm your mom, I'm your mom, mom, I'm your mom, repeatedly to this baby robot. Then this baby robot learn if this big robot is mom.
I think.
No, my point is, you know, like, let's say he's my mom, and then, you know, like, if somebody says he's my mom and mom, the baby will eventually say mom to them. Unless
So there are other persons saying, this is your mom, this is your mom.
Yeah.
So there is other person introducing mom to you every time a lot. So is this how you run mom, Sanjay? There are other persons saying, hey Sanjay, this is your mom.
I think one way to.
I think so,
So
because
this
you
is-
really don't know what is the reality, right? I mean, like, who knows, like, sees my real moms? Other people constantly say this, okay, this is mom, and then I have kind of, like, my understanding will rise with the time as
So
well.
how this baby understand?
Maybe not just
There is a
Instinct as well.
another robot saying there are one robot here, mother robot, and there are 4 robots, and there is a baby robot, and this agent goes to baby robot and say, this is your mom, and go back, and this robot goes to this robot, this is your mom, and this robot goes to baby robot, and this is your mom, things like that, infinitely. Then can this baby robot learn, this is your mom?
My assumption
Yeah,
is that.
it's like in human case.
That
Yes,
is how
but
humans
if
learn, but-
if you think about that robots, so there is a kind of how you are going to tell them where it is going to training. But if you think about the human, so in human, yes, because in a family, my mother told me, I am your mom. My grandfather told me, bring where is your mom? So you are with your mom. So somehow they are pointing to some particular person with a mom. So with a baby mind, it has started learning, okay, this is your mom. The same thing happened with the orphanage who got separated from their original father and mother, and
But
adopted.
here is the problem, just to give you an example. Your father call your mom by name. Your grandfather will say Doro to mom. So this mom has many names from whenever they live for them, right? And how this baby agent know when the grandpa says bring your mom, then how this so
Maybe
Yeah,
some kind of
that's
intelligence
actually
already inside.
perfect particular example. If you see many person, so they tell their parents or grandmother or grandfather as a mummy, because they always sees them. Their father is telling mummy, and there are some person who tell them
Some
in
people
their
call their
language, like
grandparents
not
also
a
mummy.
grandpa but just say mummy, because he is saying
He's
his mother
like
telling his
teaching, yeah.
So that's the baby.
I
learning.
think this is the how this your baby learn. Go bring your mom and go to when the agent goes to the something, it gets the reward,
Yeah.
right? So that is the how they taught the basic languages. And what will be the problem here?
How to define
So,
the-
or how we can, if we do this a lot, can it learn human language? How, what will be the next step?
more complex captions. I mean, this is very
Association.
Yeah, so how, what will be the more complex caption? Give me an example.
um,
Uh, getting the story out of the picture, like context. So if you have shown a photo kind of thing, someone is on a beach or walking. So we know if there is a beach, they are walking. So, but actually, what is happening behind that, the whole story, like one paragraph story, which actually depict the what is the context of that.
So
picture.
let's say there is a photo with a beach and human. So how will you give it the reward to the agent? When the agent can get the reward with this photo?
Again, depends on what the system we are developing. So if agent is able to tell me, okay, there is a beach and there is a lady on a beach. So if we are happy with that information, then we will give the information, but give the reward. But in past we have talked about the image captioning. So that's the toughest part. So it's not just about like beach and the lady. The context, maybe there the beach, the lady is walking on a beach. She may have feeling the sad, and her body language is saying, depicting she is sad. So the language is generated like that. A sad lady was standing on the beach looking at the sunset, and he has no expression on his face. So this is the tough thing to get out of images. So that's kind of intelligence which we possess. When we see the photo, we can
So
get out of it.
let me clarify here. So Bhaskar, what you are saying is that if the agent can say, for example, seeing this, oh, there is a green, there is a green short pillar. If the agent say green short pillar while looking at some images, the agent get the reward. What do you mean by the model describing suddenly changes to image caption model?
Like say, if think about in this photo only, if I think about as a particular human, like what I figured out from this figure. So it looks to me there is a.
So the model is speaking now.
No.
It generates a text itself and gets the reward. This agent gets the reward when it goes to the object it describes.
Yeah, there should be some kind of association between what you say and what you're trying to do, right?
What do you mean?
Like when you say go to the red pillar, right?
Mm-hmm.
Once you go to the red pillar, then only you reward it, right?
Yes, that is how this agent behaves.
So what I meant by making the caption more complex is, say the same thing but in a house, and say you're in the living room and someone tells the agent, go get me a glass of water.
Mm-hmm.
But now that glass of water is not a direct object, he may have to go to the kitchen, do something to fill it up and then come back.
So how this model will learn to go to somewhere with a glass to get the water and come back. If you study the reinforcement learning algorithms, it explores this space a lot. And one day it just gets the reward, right? When it by mistake, by pure random action, hit the glass first, and then go to the where the water tap is, and comes back, right? So this thing in a realistic house, and this agent is randomly behaving, and it has to do this thing before it gets the first reward. And once it gets the first reward, it does not know, because if this action was come to the glass and this, because you might think it did this thing, but actually this thing did many random actions, right? So it does not know which of the random action was actually helpful. So it just rewards all of this random action, and many random action, let's say going this direction, was useful because it was here, but when the agent here, then going here is actually worse. So it takes a lot, simply a lot, to learn complex behavior by pure random behavior, right? So that is the why after people developed this, they do not go directly to the more complex thing, right? If it takes 1 week to train, now it can easily take 1 year if we make a simple condition. So how many people knows the paradox of the one video game? So I think before we finish, we will go to look at it's something like a Monte Cristo's game, something like that.
Is it Montezuma's Revenge?
Oh yeah. So do you know the
Montezuma.
Montezuma's Revenge? Anyone knows what is Montezuma's Revenge? So So the game looks like this. The agent has to go to get the key and goes to get the on a door, right? Get the key and go to the door, right? That is the Montezuma's Revenge game. And the reason why this game became famous was that out of 20 or 16 or whatever Atari games, this one was the game that has a very poor performance. Other games, some games, they achieved the superhuman score, but for this game, you cannot just learn how to do things properly. The reason why you cannot do is it's very difficult to get the reward. You first have to get the key and go to the door. And by pure random action, it just took so many actions before it can get one reward. And that's why this game was really bad. And it became the motivation for many algorithms, and obstacle tower is also inspired by this. Do you remember why at level 5 is the
They introduced keys.
the threshold for the round 1? What happens at the round 5?
Maybe needs to explore.
You need
No,
to
they
get
get
all the
keys to open it.
Yeah, right. So that's why using this algorithm, you will probably not solve this unless you run it for like 2 or 3 years. Okay, so that is the thing we want mitigate. So we will continue next week the discussion. So here is some teaser.
Where's Spot? Where did he go? Is he behind the door? Is he in that spot? No, that's not smart. Let's see. Is he in the piano? Look. Is that spot? No. Let's see. Look. Is spot under the rug? Is that spot? No. Is he in the box? Look. Is that spot? No. Is let's see. Is spot
All
in the
right.
bed?
See you guys
Is that spot?
next
No.
week.